Hello everyone. Welcome back to our session on Agentic AI. In the past few sessions, we have covered a few topics on machine learning. So today we will see how we can use those algorithms in a PECAR loop. Okay. So our first scenario is very basic. Earlier in one of the other sessions, I had already shown you how to use um, uh, uh, linear regression in a PECAR loop. So today we will take a look at how to use basically decision trees in a PECAR loop. Okay, so now let's get started. Okay, now to begin with, we'll use the same scenario if you have not seen my earlier videos. So please take a look at the loan data. So basically, I've used the same loan data to create my decision tree, and then we'll be going about it. Okay, so now let's get started. Okay, so to begin with, I will first import few libraries. Import pandas as PD, then import numpy as np, then from scikit-learn model selection, import train test split. Okay, and then okay, and then from scikit-learn dot ensemble, import random forest classifier. Okay, now we are good to go. So next, we will import. Once we import this, um, in the next line, we will, this will be the step one, as I've been doing earlier. So we'll be creating the brain training. Okay. So we'll use or create a data frame, read underscore CSV, but the data set we will be using is load underscore data dot CSV. Okay. Okay. Now, next, we want um, to to create dummies. Okay, I'll use the get dummies function just for the purpose column. So I will use the get dummies. I'll create separate columns for each purpose value. Okay, so now basically I'll create a new data frame. I'll call it as final data, and then I'll use pd dot get dummies purpose. Yeah, this looks good. Df get dummies, drop first true. Okay, now next. Okay, next we will create our, or we'll separate our input and output variables. So as you can see, like I'll use x final data drop not fully paid, and then axis one. So and then I will use y as final data not fully paid. So I'm separating basically the input, and x being my input parameter and y being my output parameter. Okay. Now, next, basically, I will create the train, X train, X test, Y train, Y test, all these data sets. And if you have been following my earlier videos, you'll know exactly why I did this. So I'm splitting it into a ratio of 70-30, and then random state, I'm using it as 101. Okay, so next, I'm good with this. Okay. Now, next, basically, I will use, I'll go with random forest or random forest classifier. This particular for this particular, I mean, uh, class that I have imported earlier. So RFC, I'll create a variable RFC, random forest classifier, and estimators. We will keep it for now. We'll just keep it as 100 estimators. So by default, it's giving me 600, but I'll use 100 estimators. Okay. Now, next, once I've created this, then we'll go for the fit and we'll map the X train and Y train. And then next we will, I mean, for now, we will not create the prediction values. We will create the prediction values in the end. Okay. Now, the next section is basically the agentic class that normally we create. Okay. Now, to create the agentic class, I'll create a class. I'll call it as um, LoanAgent. Okay. And then I will define init self model. Okay. Okay, I'll define self model and then I'll define model columns. Sorry, model columns and yes, model columns. And next, I will go ahead and uh, create some variables as well. Okay, the first variable is I'll call it as self dot brain. Okay, and I'll pass in the value model. Okay, the argument that I've created, the parameter that I've created model. And next I'll use self dot columns, and here I'll pass in model underscore column. Okay, next next we'll define another function. So we'll define, or this is basically the we'll start with the per char loop. So this particular function will create the per char loop. Okay, so we'll create run per char loop, and then we'll define the parameters. So self obviously will be the first parameter. Self, then the second argument or second parameter I'll use name. The third parameter will be uh, raw data, and I don't want this. Okay, now I want to define or create a message first. So I want to create a print. Okay, and then I want to use, then I want to come to the next line, and then I want to define the per char loop initiated, or I'll just use per char loop, and yeah, so that is fine. Okay, per char loop name, that's fine. Okay, next I will just go ahead and then we will create the perception part. Okay, so once this initiates, the first step will be creating the perception part. So in the perception, basically we will um, from the raw data, we will extract the FICO score. Okay, so first we'll extract, create a variable, we'll call it as FICO, and then raw data FICO, raw data, then the FICO value, the FICO column that we have. Okay, yeah. So now we can get FICO. Next, I can just go ahead and print out this FICO score. Okay, and then I will also print out purpose. Okay, so FICO score, and then I will also print out something called as purpose. Okay, raw data purpose. Okay. Now, next will be the reasoning part. So first the perception is completed. Next, we are going to create the reasoning. So I'll use thought I'll add some message like, checking this profile for the name of the individual, right? So I'll use name. Yeah, that looks good. And then I will also use what algorithm that I'm using. Okay, applying random forest model. Okay, so this will be my reasoning part. Okay, now once the reasoning is complete, then I also want to print that particular variable. So let me just also print it. So I'll use print reasoning. I mean, sorry. Okay, uh, I can use thought, or this is just a text, right? So for now, I just so that I can isolate, or I can define when is the reasoning part coming. So I'll use reasoning and print reasoning thought. Okay, so now we are good. So for the thought part, next we will go ahead and define the action part. Okay, so in the action, basically we'll create a dictionary with exact columns from training. I mean, first we'll set all set to 0, and then we will create a for loop to keep adding different items. Okay, so let me just show you encoded input, and then I'll use columns. Okay, and now next I've created that variable encoded input, and now I'll go ahead and start adding or putting the values within the raw data. Okay, so now so I'll just add a for loop. I'll create two variables, k and v. Okay, and in raw data, okay, kv. Now if k in encoded inputs, one second. K in encoded input, then encoded k is equal to v. And next I will write elif. I'll go for elif k is if it's equal to purpose. K is equal to purpose, and then I'll use column name is equal to purpose v. Yeah, this looks good. Okay, and then next step would be like will I mean this is like a fix, like only set one if the column actually exists, if our if we have in our brains feature. Yeah, let me show you how we will do it. So yeah, so exactly what it shows, if column name in encoded input, then encoded input column name is equal to 1. Yes, looks good. Now, finally, we'll write our else um, else we will just we'll just uh, pass. Okay, we'll add a pass. So basically we can if in the else part, normally, like if you have seen my earlier classes and have not discussed about pass, so whenever I'm writing an if else statement, so if there is under if there is a condition, and under else there is no condition. Okay, in that particular scenario I will just use pass. If I'm not using pass, I'll start getting an error because it will expect something at the else part. So whenever you're writing if else, okay, or in any other cases, like if you don't want to pass any values within the else part, then you can just use pass, so that it will just bypass it and your code will run smoothly. Okay. Now, um, next, basically, next we will make sure or will ensure column order matches exactly what the model expects. Okay. So to do that, we will use this. Okay, input, we'll create an input data frame which is equal to pd dot data frame encoded input, and then to match it we will use, okay, to match it we will use self dot columns, okay. Okay. Now, next we will create the prediction values. Okay. To create the prediction values, we'll create this prediction variable. So self dot brain dot predict input df, and then in the input df, the first column basically. Okay. So that's why the index is 0. Okay. We'll use that particular column. Okay. Next, okay. Um, we've now once we have created the input column, next we will create another variable. We will call it as risk. Okay, it will call. I mean, it will be like if the FICO score is a certain value, then it will be high risk. If or else uh, like if the FICO score will be a different number, 0, it will be low risk. Okay, so to do that, I will create a variable. I will call it as risk. Yeah, it says high risk if prediction is equal to 1, and else low risk. So yeah, so this looks good. Next, we will just go ahead and print. Okay, and we are just printing decision, the loan application for result. For name is classified as you can print. So this will be your completely like personalized message, whatever you want. We can print that. Okay, so for now, I'll just go ahead. Okay, this message looks quite good for me. Next, I will go ahead and then we will come to the reflection part. Okay, now in the reflection, or actually the result, uh, that will tell you whether what you have to do. Okay, so for a particular client or for a particular uh, 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 customer, whether you should approve the loan or not. So this is the part in the reflection where you define that. Okay, so if prediction is equal to 1, then I will say okay. If prediction is equal to 1, the decision will be deny. So low risk client, so deny. Okay, and then again, next, again I'll write another condition, elif uh, prediction is equal to delay. If in the elif condition, I will write uh, FICO. FICO is less than 680. Okay. Then I would say decision. I would give the decision like pending for further review. This is fine. Okay, pending for further review. Then else, I mean, you can write multiple cases or multiple conditions, but I'm limiting to only two conditions. Okay, and else if the decision, if it doesn't satisfy any of these conditions, then you can just go ahead and approve. So else, yeah, decision is approved. Okay, so yeah, else decision is approved. Okay, now this will be our per care loop using I mean random forest using per care loop. Okay, this is how we will define it. Okay, now once we are done, so let me just save it. Okay, now we need to run this run this particular or run some of the scenarios. Okay, now to run some of the scenarios, I'm having some values. Let me just copy them and just bring it here. Okay, now once I'm done with my loop, then I'll have some scenarios. Okay, so these are my scenarios. Okay, so now if you take a look at my scenarios, for the first customer, Sophia having credit policy one, then purpose and all other stuffs are available. Okay, then second customer is again small business, high data risk. This one I have defined it because I generated this information from agentic tools. So basically you are getting this information, but yeah, in real time you just get the I mean, you could get a table, you can get it in this particular format. It could be anything. Okay, now once we have this particular information, I mean, or this particular scenario, or even before running the scenario, so basically I have to create a variable, and then in that variable itself I have to define that particular uh, class that we have defined earlier, right? Like loan agent, right? So let me just create that. So this is like my object that we are creating. Agent is equal to loan agent, and then RFC X columns. Okay, here I will just add to list. Okay, I'll convert this X columns, X dot columns into a list. So I'll use this to list. Okay, and once I have created this object, next I will use or then I will pass in the scenarios. Okay, now next, once I have created the object and then I have defined the scenarios, now I have to run my object into for this multiple scenarios, right? No, so now to run my object for multiple scenarios, so this is how I'll define. So for um, yeah, name data in scenarios dot items. Okay, and then agent run per cab loop. Okay, so yeah, this is how I'll run it. Okay, now that's it. So I think we're good now because I've already had a print at the end of my per care loop. No, I have not added a print. Let me just add that. Okay, I can even add it here. I don't have a problem with that. No, I'll okay, 1 second. Yeah. mm, it's better I add it in the per care loop itself. Okay, after this else, I can add name decision, but since I've already printing name multiple times, I don't want to again print name. So final decision based on the model prediction and FICO score, the loan application is, I'll keep it simple. Loan application is decision. Yeah, this looks good. Okay, so now we are good to run. So let me see if there are any errors or if something I've missed. Any highlighted or underlined values or nothing, all looks good. So now let's go ahead and execute this. Okay, so now, okay, so now if I go ahead and execute this, fine. Okay, so now you see for my different uh, clients. So this is the decision. Like for example, for the first one, Sophia. So the FICO score is 820. So the purpose home improvement. So reasoning checking high risk profile for Sophia, applying random forest, and action is the loan application for Sophia is classified as low risk. Okay. So next. Final decision based on the model and FICO, so loan application is to be approved. Okay. Now next one, again low risk, can be pending further review. And then final one, 672, this is also low risk, this is also pending for further review. And then another one, yeah, this is also pending for further review. There is no rejection, but yes, if there are some values which are having rejections, it will also show those values as well. Okay, so you can include the conditions that are needed in the if section, whether if you want a particular what should be the output, like the final action, or what we call it as the reflection, right? So in the reflection step, so basically here itself we can define whether what decision that we are going to take. Okay, so this is one example. Another example I will give you, basically, uh, in this next example, suppose I'll give you the scenario. Suppose the same in the same loan agent, okay, in the same loan agent, if I'm trying, let me just create a new file first. Sorry. So, i- another example is, suppose I'm using the same data, but you see, we have gone through multiple algorithms, right? Now, I'm not sure which algorithm to use. Okay. If I want to find out which is the best algorithm or which is the most accurate algorithm, so I can run all the algorithms together. I can put the data set and then I can create uh, multiple models. Okay. And then I can find the root mean square error to identify which is the best algorithm for this particular data set. Okay. Now, to do that, I am already having a code. I just pull in that piece and then I will explain. Okay. Now we can call it like an algo checker or something, and this is the file name that I have created. But yeah, so we can call it like an algo checker. So basically, these are the libraries that I want. Since I am doing both, I'm comparing logistic regression, decision tree, and neural network MLP. Multi-layered perceptron. Okay, I'm importing these three algorithms from scikit-learn, or these three classes from scikit-learn. Again, the process is pretty much same. So I create a class loan comparison agent. I define I mean, I create an init function, then I define the input and another argument data for the data path. Okay, then again I go through first in the perception step. I identify, or I just create the file path, a variable, or create a variable for the file path. Then I go ahead. Sorry. Then if you see, almost the same in the processing pre-processing part under the reasoning. So basically I create final data, and then I separate it into test, train and test input and output variables. And then basically I'm using standard scaler. Earlier I did not use it, but yes, I'm just using scaling, so that to make the data uniform and make it more in terms of smoothing. I do a bit of smoothing here using standard scaler. And then if you see, first I'm using logistic regression. Okay, here there is another parameter called maximum iterations, just to bring it to an accurate model, or make it more accurate. Then I'm using decision tree random state 101, and then again I'm using MLP classifier. So basically, these are the three results that are getting populated. Okay. Now, once I populate the result, so then I'm just printing out some scores and stuff. And then finally, in the uh, in the execution step. So basically, the result is a comparison of X and Y. Okay, what is the difference or accuracy in terms of X and Y? And then finally, I'm you know comparing and running it through a loop, and then I'm just printing it out. Okay, and since I have created the path of the file as a parameter here, so I'm passing the path of the file as a parameter in my object. Okay, so now basically, since there are three uh, algorithms that I'm comparing, so basically if I just go ahead and execute, we can see in the perception step, so it says how many steps loaded, because I had created earlier how many steps loaded. Okay, length of the data frame. Reasoning I've already defined as something here in the reasoning. Okay, and then finally I'm getting the result. It says executing model training tools, logistic regression accuracy 0 0.8, decision tree accuracy 0 0.7, and neural network accuracy is 0.8420. So depending on that, logistic regression looks most accurate. Okay, and the decision trees, there's some standard messages that I have provided, but yes, you can always you know customize this one depending on your requirement, and depending on what generic output that you need. Okay, so hopefully you have liked this particular session. So basically, this is how we use different algorithms within PECAR loops, even in your agentic AIs at the backend. In a lot of cases, these algorithms get used, but you just I mean, you are just focused on the output part. Some of the agents, if you ask them exactly like generate how did you get to this particular conclusion? When they generate the logic of it, you will be surprised. Like you will find either it will be a neural network, or it will be a regression, or it will be something related to that. Okay. So with that, I'm ending today's session. Please keep watching for more upcoming interesting videos. Let's catch up in our next session. Thank you very much for joining.